Hello and welcome back to Steamer with Steve. Today we're going to keep going on with our binary numbers and we're going to move on to how to do subtraction. So we've done addition now and we've done that process, and hopefully you'll see that subtraction isn't that hard. Now there's a couple of different ways of doing subtraction. We're going to show how humans normally do it, and then we're going to show how a computer actually needs to do it. So subtraction, if we had 1, 1, 1, 1, 0, take away 1, 0, 1, we would follow through exactly the same as you would do normal subtraction. And that would mean you go through the columns and borrow if needed. So if you did 0 take away 1, you can't do it. So you need to borrow across, and then you would get an extra 1 across there. 0 take away 0, it gives you 0. 1 take away 1 gives you 0. 1 take away 0 gives you 1, and then 1 take away 0 gives you 1 again. So then you have 1, 1, 1, 1, 0 minus 1, 0, 1 is equal to 1, 1, 0, 0, 1. So, or 30 take away 5 is equal to 25, which is what that aligns to. So basically just follow the columns, take them away, and borrow across if you can. So just pause the video, have a go at those ones. Awesome. So the first one you should have found is just 1. The next one again is just 1. This one here was 1, 1, 1, 1. This one here was 1, 0, 1, 0, 1. This one here was 10, 1, 1, 1. And then number 6 was 1, 0, 0, 0, 0, 0, 0, 1. Cool. So how does a computer then use add to subtract two numbers? Well, this is what we talk about when we talk about 1's complement and 2's complement. So this is where it gets a little bit different from using those signed values that we sort of played around with before. So can it do it? Absolutely. So if we look at a binary number compared to a decimal, at the moment we go 0, 0, 0, 0, 1, 0, 1, 0, and 0, 1, 1. And you should be able to convert those pretty easily. When we consider the negative values, if we think about what happens here, negative 0, negative 1, negative 2, and negative 3. Now I've included negative 0 because this is one of those flaws in the system when we sort of deal with it. Now there's a quick little video there that you can have a look at that can give you a bit more insight. But I'm going to unpackage how those get converted, which is what we're going to look at. So how do you invert a number? Well, it's really easy. You simply swap the value to the opposite number. So if it's a 1, it becomes a 0. If it's a 0, it becomes a 1. And this is totally dependent on the number of bits. So you just go through a 4-bit number. If you invert it, it needs 4 bits for the output. And that's pretty simple. So basically 1s become 0s, 0s becomes 1. And this is effectively what 1's complement is when you hear that term. So 1's complement is basically when you just invert the number. So this number here, 1, 0, 0, 1, 1, 0. If we converted it and became 1's complement, it becomes 0, 1, 1, 0, 0, 1. Another way of thinking of it is you just flip the bits. So your turn, try and find the 1's complement for this one. So 0, 0, 0, and hopefully you found that was 1, 1, 1. Then 1, 0, 1, 0, if we flip the bits, you should find that 0, 1, 0, 1. 1, 0, 1, 1, 0, 1, 1, 0, 1. If you flip the bits, becomes 0, 1, 0, 0, 1, 0, 0, 1, 0, and hopefully you found that. So if we use 1's complement, basically all we do is make a little mirror. So this is why we have negative 0. So the 1's flip around, so 0, 0, 0 becomes 1, 1, 1. So that becomes what negative 0 is equal to, which again doesn't exist, which is one of those flaws. 0, 0, 1, if we flipped it, becomes 1, 1, 0. So that's what negative 1 becomes. Negative 2 becomes 1, 0, 1. And then negative 3 becomes 1, 0, 0. So if you follow through each one of these, you'll find that the values should be following against each one. So note the negative 0 is not a real number. And that's really important. So with our integer representations, we've got 0, 1, 2, 3, 4, 5, 6, 7. A positive number is 0 in the leftmost column. And then they go like that. If we have unsigned values. When we have include the negative values or the negative versions of those numbers, we basically just invert them. So 0, 0, 0 becomes 1, 1, 1, 1, and the zeros just becomes the 1s all the way through. And that's effectively how you get a whole heap of different numbers. So notice down here, negative 7 is 1, 0, 0, 0 because you've just inverted the numbers. So however many bits represent how many different options there are. So if the original number was 8 bits, you need to invert it with 8 bits. Now there's two different ways of subtracting with 1's complement. Case 1 and then case 2, which is what we'll see. So if we had 58 take away 43, we would get 8 take away 3, which gives us 5. 5 take away 4, which leaves us with 15. So that becomes 1, 1, 1, 1. So let's just leave that number in the back of our heads as we go through this. So this is if the carry is produced. So if we had these two numbers taken away from each other, notice that I'm using base 2 notation. What you should find is we first write down the number. The next step, then we invert the other number that we want to subtract. And then this is where it gets a little weird. If you add these two numbers together, you should see something really neat that happens. So if we add them together, we get 0, we get 1, we get 1, 1, 0, carry the 1, 0, and then carry the 1. We then take the carry from the first column. So remember, if we only had 6 bits, which is what this number had, and this has 6 bits, the output should only be 6 bits. So if there is another number here, we take that and then add it on to the original number. So if we add that on, we get our original thing that we remember it should be. And 1111 is the same as 15. How cool is that? Now this is effectively how a computer subtracts numbers, and it does it by addition using the binary math that we just covered there. So your turn. Have a go at that one. So pause the video, see if you can follow the steps. Cool. So what you should have found is just, I like converting the decimal just to make my life easier, is we write the first number, then we invert the second number to be subtracted. We go through the process of adding those numbers together, like so, and then we've got an extra bit on the end. Now because this is a 6-bit number and we've got a 7-bit output, we would then take that one, add it onto the first column, so take it across there, add it on, plus 1, and we get 1, 1. Which if we think about it, 54 take away 51 should equal 3. So a little refresher, if you had a number that's smaller at the top and you take it away, we actually get a negative number. So another way of doing this is we take away the whole number and then just put a negative symbol on the front as well. So 11. So if the first number is bigger, you can still do this process. So the first step is you do 1, 0, 0, 1, 1, 0, and then invert the number to add onto it. Add the two numbers together, so you get 0, 0, 1, 1 plus 1 plus 0, 1 plus 1 equals 0, carry the 1. 1 goes down, and then you've got a 1. And then, if you don't have an extra column to add on, this is when we just invert the number and whack a negative symbol on the front. So that becomes that, and that becomes a negative 11. Pretty cool. So that also works as well if you don't have the carry. So notice that it's like a binary decision. If this is here, do this other pathway, otherwise do this. Have a go at this one. So 1, 0, 0, 1, 1 minus 1, 1, 1, 0, 0. So 19, take away 28. Pause the video, have a go. So the first step is you write the first number, 1, 0, 0, 1, 1. Then you write the number to be inverted, so you flip the bits. Then you add the numbers together, and you get 0, 1, carry the 1, 0, and then 1, 1. Then we invert the number back, so we get 1, 0, 0, 1, 0. And then to know what this number is, we just jam a negative symbol on the front. So that should be negative 9, sorry, there. Pause the video, have a go at those. Cool. So I'm not going to go through each one of these because it's just going to take too long to write out them, but you should have a good understanding now of how to add and then also subtract your positive and negative numbers. Hopefully that's given you some insight. If you have any questions, please put them in the comments down below. Yeah, these are quite tricky when you're starting off. Oh, sorry, you probably can't see those last ones. I'll just hide that quickly so you can see. There you go. And then, yeah, thank you very much. If you do have any questions, put them in the comments down below. Give us a like and subscribe, as it does help with that YouTube algorithm. And yeah, see you next time on STEAM with Steve. Adios.